Alright, so this is part D of question 2. So the question is, find the acceleration 10 seconds after she jumps. So I got my function, right, which goes like this: 1 minus e to the minus 0.2 times t. Right, so we need to find the acceleration, okay, so two ways of doing this. I would probably expand this equation first before I do anything, alright, because as you can see, the first term is a constant. So this part is 50 minus 50 times e to the minus 0.2t. Right, so when I differentiate it, I should end up with 50 times 0.2. Okay, the reason I have 0.2 rather than minus 0.2 is because the minus and the minus cancel out. Then I have just the exponential. So this should just be 10 e to the minus 0.2t. Okay, so this is my acceleration. Find acceleration 10 seconds after she jumps. So all you have to do is plug it in the calculator, and this becomes 10 times e to the minus, and plug in 10, this will be e to the minus 5, right? Is that right? No, sorry. I'll plug in 10, it'll just be 2, right? And I'll leave this up to you to plug in because I don't have a calculator right now. So part 2, find the distance that she has fallen in the first 10 seconds. Give your answer to the nearest meter. Okay, so now we're going the opposite way. We're going to integrate it. Okay, so v is equal to dx dt, right? And to get x, we simply need to integrate it that way. Find the distance that should fall in the first 10 seconds. So I have to put these in 0 and 10. Okay, so writing this out, x is equal to, so the 50 I'm going to take out of the integration, and this will become 1 minus e to the minus 0.2t dt, 0, 10. The first one should be really straightforward, first term. So this is 50 times t. The second term should be, okay, just write out the exponential just as it is, 0.2t 1 over 0.2, and because it's a minus, the minus plays along with this minus and becomes a plus, right? And then 10, 0. Okay, you can differentiate this if you want. So when I differentiate this, this minus 0.2 comes up front and becomes the minus 1, okay, which is what we have over here. Okay, so putting this back, so putting these values in, you should end up with 10 plus, so that's a 5 times e to the minus 2. Okay, I made one mistake up here. No, sorry, no, I didn't. Okay, so it was minus 2. Okay, minus, so when I put 0 in, that's going to be 0. It's going to be 5. So it's just going to be 5. So e to the minus 0 is just 1. So now I end up with 50 times 5. In fact, I could have, I'll show you what I'm going to do. 50 times 1 plus e to the minus 2. Okay, and again, plug this in the calculator for yourself. All right. Okay, thank you.